All right, hi everyone, welcome back to Stats. So from this point on, the class is all going to be online like all your other courses. So I'm sure for a lot of you, you've never taken an online course. I've also never taught an online course, so this is all really new to all of us. So basically, how this process is going to work is I'll be posting a few short videos every week rather than doing lectures, focusing on a specific part of the content for each week. I'll be posting this in the discussion board on Moodle. So I would say if you have questions about the lecture, I would add those questions in the discussion board first of all. And if you have any additional questions, you can always set up a Zoom meeting with me. So since I'll be doing all these lectures from home, I'll also be having a guest lecture. So this is my pet chihuahua, Raja. I refer to him as Professor Raja. So I'll be having him join us every once in a while to give his feedback. And obviously, since he's so cute, he'll make the videos a lot more entertaining. So for today, we're going to be talking a little bit about how to do confidence intervals in R and how to interpret confidence intervals. And then I'll be talking about a couple of practical examples where you might see confidence intervals in everyday life. All right, so let's jump into talking about confidence intervals. So you'll remember before the break that we were talking about how when you have a normal distribution, it goes from the bottom of the range to the top of the range, and there's a lot of points near the middle. And then you can look at the probability density, which is if you look from one point to another point, how much of the distribution does that cover? So if you're looking at, how much of a range is likely to happen, one thing that you'd want to look at is the confidence interval for an estimate. So when you're looking at a confidence interval, the standard is to use a 95% confidence interval. So like a lot of things in statistics, this is a little bit artificial. You could look at the 99% confidence interval, 90% confidence interval, but you see 95% confidence interval most commonly. So what is that? Essentially, this is you get an estimate of, okay, this is the percent of people that we think are going to vote for this candidate. And then you can say, by random chance, it could be off by this amount. How confident are we that it's pretty close to that? And so for a 95% confidence interval, that essentially means that you would expect by chance that 95% of the time it's going to be between this lower bound, so a lower value, and an upper bound, which is the upper value that we would expect. So you can actually do this with standard deviations. So I'm just going to be popping this down into our console here and run this quickly. And so what this function is going to be doing is it's going to be looking at, based on the normal distribution, what would be 95% of that normal distribution. So essentially, this is cutting it off at the 2.5 percentile and 97.5 percentile. So the outer 2.5% is cut off. It's basically saying, how much does the other 95% take up? So if you run this in R, we get values of negative 1.95, et cetera, and positive 1.95, et cetera. So how you interpret that is that 95% of the values by random chance are expected to be between negative 1.96 standard deviations and positive 1.96 standard deviations. So when you hear the results being reported, you sometimes hear about the margin of error. Or if, for example, with voting for candidates, you might say 26% of people are expected to support this candidate, plus or minus 2. And usually that means that's the 95% confidence interval, that it's estimated to be 26%, but we're 95% confident, just based on what we know about random chance, that it's going to be somewhere between 24% and 28%. So this is really useful because rather than just getting, this is our best guess about how many people are going to vote, we also get a sense of how much by random chance that might vary. So this is something we can use to help make sense of the data as well. So This is something that is also affected by sample size. So the bigger the sample size you have, the smaller the confidence interval is going to be. So I'm going to start with this first example. And with this, I'm setting n to 10,000. So again, n refers to the sample size. So this is imagining a pretty big sample size of 10,000 participants. So again, just popping this up into the global environment. So then what we can do is get the confidence interval for this. So I'm dropping this function into R. And what I'm getting here is that the confidence interval here is 1.96. And so then if you come and make the sample size 10, I'm now going to be making n a value of 10 rather than 10,000. So this would probably be a pretty small sample. You'll see this is, again, popping over here, and we're using that value. Now we're putting this in, and that is 2.26. So essentially, if we have a huge sample size, the top end of the confidence interval would be a little over 1.96, but pretty close. If it's a small sample size, it's basically going to be widened out. So that is another way that sample sizes are very valuable. Your estimate is going to be more precise in that you're going to have a smaller confidence interval. Small sample means you're going to have a larger confidence interval, which means your best guess, there's a lot more variability to what you might expect that you would find. And you'll notice that with 10,000, this is getting really, really close to this true normal distribution of 1.96 or 1.959964. So what you'd find is that if the sample size was actually infinitely large, you'd get to this normal distribution. And essentially, larger confidence intervals as you have a smaller sample. All right, so I'm going to be doing some functions with the LSR package here. And so I'm going to be running this as if I hadn't had LSR installed already. So some of this is going to be a little bit redundant on my computer, but again, just going through it to show you how that would work. So this is installing LSR, and then I'm going to make sure that this is loaded up in the library. All right, so I'm actually going to be using the AFL, American Football League data again for this. And we're going to look at some confidence intervals for those estimates. So I'm loading up AFL24.R data, which again is going to make it so that all of that stuff is going to be popping up into our global environment. So again, we have this data frame for the AFL data with 4,296 observations and 12 different vectors in that. Right. So for this, I'm going to show you a confidence interval for the mean value. And so for this, it's using that variable attendance, and it's giving you a confidence interval for that estimate. So let's run that first. And you see here that there's a 2.5% confidence interval, 97.5% confidence interval. And so what this is telling you is that we can be 95% confident that the average attendance was somewhere between 31,597.32 and 35,593.12. So again, this confidence interval is going to be pretty small because we have 4,296 observations, so a pretty big sample. And so the estimate is going to be pretty precise. So this is essentially telling you somewhere in between these two values is probably what the actual attendance is, assuming that our sample of people attending the game is representative. Right. So I'm going to show you an example of a couple different plots for what confidence intervals look like. So I am going to install a new package here called Psych, which is something that you can use to graph confidence intervals. And then I'm going to add that into my library. Remember that when we're making graphs in R, it usually needs a lot of space. So I've made this a lot larger here, so it's a little bit easier to see. So the first thing I'm going to do is I'm going to make a bar graph. And in addition to it showing the means, it's also going to have a 95% confidence interval plotted. And so you see here that it's attendance and it is split by year. And then there's a few other things that are specified in here as well. And so you'll see here that you have the average attendance for each of these years from 1987 going all the way up here into the 2000s. And so you see that there's a mean plotted. So this is the average number of people that attended each game during each of those individual years. And you'll see that there's these lines here, and the top of it is the upper level of the confidence interval, and the bottom of it is the lower end of the confidence interval. So this is useful because you may be looking and comparing years and saying, well, it looks like, say, 1988 was a little bit higher than 1987, but you can look at that and see, well, those confidence intervals actually overlap. So that doesn't look like it's a huge difference statistically. They're pretty similar to each other. Whereas if you're comparing 1987 to like 1998 all the way over here, you see this is a lot higher, and those confidence intervals don't overlap at all. And so it seems like definitely this isn't just a matter of, just by random chance going up and down a little bit from year to year. It seems like this might be a meaningful difference. So I'll also show you another example here too, where you can plot this as a line plot. This is going to be pretty similar to what you're seeing here. So again, this is splitting based on year, and this is looking at attendance, but this is actually going to be a line plot. And so this, again, is the same type of data, but this shows kind of trajectories from one time point to another. So this is valuable for if you have a whole bunch of points that you're looking at, or if you're looking kind of trends in the data. And so you're seeing here that there does seem to be this increase over time. And even when you account for, just by random chance, you'll expect there to be a little bit of variability. It does seem that over time, the attendance is generally going up, which seems like a good sign. Right, so to review for what we've talked about today, confidence intervals are a way of seeing how much variability there might be around an estimate just by chance. And this is most often used for the mean of a sample, in that now you can get at, what is the average in the sample, but, just by random chance, how much higher or lower could it be? Again, this is useful for if you're seeing things reported in the media. They might say it's this amount plus or minus something. And that's basically the same as looking at the 95% confidence interval, where there's the upper level, which is the plus side, and the lower level, which is the minus sign, which is important for interpreting any data, because you don't want to only know, what can you expect at average, but what is the range that you might expect just by chance.